Okay, so we have a random variable z, which is sampled from a normal distribution, not standard normal distribution. And what we try is that we have a neural network, which is denoted by this g, g theta of z, and we try to like after we pass this random variable through this neural network, we basically get a sample which is actually being generated from the parametric form of the like distribution that we assumed. So what we try is that like we define some divergence metric. We compute it over for these two distribution px and p theta. We minimize it over the parameters of the parametric form, that is p theta. Like p theta is being parameterized by theta, so we minimize it over theta. And then we like once we have solved this optimization problem, we actually get that px is very close to p theta. And since we say that once this output is generated, we like once we send a sample from the normal distribution from this neural network, we are getting a sample from the p theta x. And since we have already approximated this p theta, not approximated, we have sort of made it very close to px, the true distribution. That is like px is implicitly being estimated by this neural network, that is z theta of z. So after solving this optimization, we can try to sample from px using g theta z, because that is a neural network, and we can like we even though we don't know px, we can have some like form for g theta of z. So next we have that this is just like after optimization, this theta star will be fixed, and we just pass a z from this optimized neural network, and then we get a sample which is actually from the true distribution. So that's how we are able to generate a data point from the actual distribution. So, but we still have some questions, right? I mean, these are just sort of like what we can do. But there are still like many questions, like what should be the choice of the divergence metric? Like this optimization problem is itself defined on what divergence metric do we choose. And also like since we don't know both px and p theta, how do we really compute the divergence metrics without knowing px and p theta? Also like how do we choose the g theta of z? That is also like, I mean, we try to find out the parametric form for p theta. And once we have the choice of this divergence metric and p theta, how do we really solve the optimization problem of minimizing the divergence metric? So this is the story so far. Let me continue in the next lecture.